Ocean waves are powerful forces that erode and shape the world's coastlines. Most are created by the wind. Winds that blow over top of the ocean create friction between the air and water molecules, creating a frictional drag that shows up as waves on the surface of the ocean. The more forcefully the winds blow, the larger the waves grow. Ocean water is always in motion. Yet it is interesting to note that an ocean wave is not representing a flow of water. While ocean waves transport energy over vast distances, only a small amount of water within the wave is actually moving in a horizontal direction. Instead, the water within the wave is simply moving up and down. This is why a buoy set out in the middle of an ocean bobs up and down, but does not travel with the waves. In this lesson, you will learn more about the features of waves as well as the different types of waves and their erosive effects on coastlines. Now, if you blow across the top of the coffee in your coffee cup, you are creating miniature waves. Look closely and you will notice that the waves of coffee rise and fall. The highest point of the wave is called the wave crest, and the lowest point of the wave is called the wave trough. Waves vary in size due to the force and speed of the wind blowing over the surface. Yet they move together in groups that move across the fluid surface at the same speed and in regular intervals. This movement of waves as a group is known as a wave train. There are different types of ocean waves. The waves we have been discussing so far are referred to as wind waves, or simply waves that are created by wind. These wind-driven waves begin as ripples, which are small and have the shortest period of time between successive wave crests. They increase in size if wind gets stronger. If heavy winds from tropical storms or other wind systems drive the waves, they can create ocean swells that are capable of traveling long distances over entire ocean systems. Ocean swells are defined as mature undulations occurring in open ocean waters. Even though swells often get their start from storm winds, they can be found far distances from the region where the waves were first generated. And while they can range in size from small ripples of water up to 10 or more feet, they are generally what you think of when you imagine a fishing boat or buoy bobbing up and down in the open ocean waters. A tsunami is a type of wave that is not started by the wind. It is defined as a series of waves caused by an earthquake, underwater volcanic eruption, landslide, or other abrupt disturbance. Tsunamis can result in massive destruction when they arrive on shore. This fact became evident in March of 2011 when Japan was struck by a large tsunami that was triggered by a 9.0 magnitude earthquake. The tsunami claimed the lives of more than 15,000 people, damaged several nuclear power plant reactors, and caused billions of dollars in damage. A tidal wave is another type of wave, and it's sometimes confused with a tsunami. A tidal wave is a wave caused by the tides. Because tides are predictable events that are created by the moon's gravitational pull, tidal waves, unlike tsunamis, are predictable events. As the different types of ocean waves reach the shallow waters near the shore, they begin to interact with the ocean floor, causing the waves to slow down and increase in height. As the waves continue towards shore, they become less stable and eventually break. There are two main types of breaking waves, and their classification depends on the slope of the shoreline. A spilling breaker is a type of breaking wave that occurs on flatter shores. Because the wave enters the shoreline on a gradual slope, it dissipates its energy more evenly and basically spills onto the shoreline. A plunging breaker is a type of breaking wave that occurs on steeper shores. Because the shore is steep, the wave crest curls and plunges down over the front of the advancing wave. Plunging breakers are the waves preferred by surfers. Waves are powerful forces that continually pound on the shoreline. They cause the erosion of shoreline features and the transport of sand and sediment along the coast. Yet waves rarely strike the shore directly. Instead, we see a phenomenon called wave refraction, which is the bending of waves as they travel toward the shallow waters of the shore. This causes the wave's energy to spread out, and we see that shoreline features that project out into the water, such as headlands, receive the full force of the wave's energy, subjecting them to the most erosion. While this erosion tends to break down outcroppings and straighten coastlines over time, it also creates some of the most interesting and unique shoreline features. As waves attack headlands, they chip away at the rocky structures, leaving behind steep, rocky cliffs, hollowed-out caves and sea arches, and pillar-like sea stacks. The sand and sediment that comes from the eroding coastal structures settles into recessed bodies of water along the shoreline where wave energy is low. If this sand and sediment settles on land, it forms a beach. If it settles out in the water, it forms a type of sandbar, such as a spit, tombeau, or barrier island. Let's review. The highest part of the wave is called the wave crest, and the lowest part of the wave is the wave trough. Waves travel together, and this movement of waves as a group is known as a wave train. There are different types of ocean waves. Wind waves are waves that are created by wind. If heavy winds from tropical storms or other wind systems drive the waves, they can create ocean swells, which are mature undulations occurring in open ocean waters. A tsunami is a series of waves caused by an earthquake, underwater volcanic eruption, landslide, or other abrupt disturbance. A tidal wave is a wave caused by the tides. As ocean waves reach the shallow waters near the shore, they break. A spilling breaker is a type of breaking wave that occurs on flatter shores. A plunging breaker is a type of breaking wave that occurs on steeper shores and is a type preferred by surfers. Waves rarely strike the shore directly. Instead, we see wave refraction, which is the bending of waves as they travel toward the shallow waters of the shore. Because of this, we see that headlands, which are shoreline features that project out into the water, receive the full force of the wave's energy. This creates unique shoreline features such as cliffs, caves, sea arches, and sea stacks. The sand and sediment that comes from the eroding coastal structures settles on land to form a beach, or in the water to form a type of sandbar, such as a spit, tombeau, or barrier island.